That's okay. That's almost as loud as me. Turn that down a little. What we've got today, I have. Let's add this. Unfreeze this guy. We've got these. I don't know. I'll just pull up the image because that'll be way easier. And Teams is just gonna be probably pinging off the walls all night. Not much to be done about that. So, 1190 TrueTech GPS bracket. This guy looks pretty good. Looks pretty sharpish. And it is, in many ways, and in many respects. But it's really hard to have something that sort of sits nicely on a just, you've got a cylinder, that's all you've got to grab onto. So unless you're trying to sit flat against these faces, which by the way are not coplanar, you don't really have an easy way to control where your angle sits. So I'm designing pretty much, I'm just gonna wing this one, really. I mean, I've got this rough reference bracket file, and I'm definitely gonna save it as a new one. It's 1190 detented EPF bracket, and it's gonna be. Oh, I'm gonna end up needing a lot of parts for this, so. Oops. I was gonna tell my dad when I started, because this is who it's for, so. Started. 1,000,001 messages. I'm just gonna close that window. Solve that problem. Oh man. Okay, you need to put phone down, focus on modeling. So we've got this guy. We've got a couple of extra configurations, so we're gonna delete those. Say yes, yes. Call this one default. Default, rebuild. It's gonna try and fit default in there because software dumb, but well, that's easy to fix. Just get rid of that sketch there with the text. So we got these two guys, which means we got a profile that we can extrude between, and I have to think about. Let's see, which way's forward? So what do I get for immediately closing? Okay, so the swoop out is forward, which means this is the correct orientation, which is good. So we want roughly, let's see. So many messages. Hope we just mute them. Okay, so let's walk this back a little bit. We need to start from pretty bare bones, and I don't know why I have mate references on here. That's dumb. We've got this boss extrude, which is going the wrong direction. Ooh, I see. Now we've got that guy too. So we're gonna make that one construction. Oh, which way do I think is forward? Exit sketch and rebuild anyway. We'll let that error be an error. Of course, I immediately close the window. So we've got this guy, and clearly this is the dash pointing out this way, out forward and out of the screen. So the swoopy bit is forward, which I think, now that I've broken the model, I want to say it was 3 mils thick, so. Oh, it doesn't want to be a thin extrude now, that's kind of rude. Can I keep that line not construction and still have it be a thin extrude? Thin feature, one direction, selected contours, clear selections. I don't get the selection manager, which is rude. Oh, sorry, yeah. Let me undo a couple of things here so that we have a part again. The dash does point backwards towards the rider, but because of the way that I'm modeling it and because I'm kind of lazy, forward is towards this corner of the screen, so I'm considering I'm considering the front, the side that I'm facing towards, even if it's facing backwards, because I don't know, that's the way I modeled it. I could certainly model it the other way around, but then anytime that I hit like Control 1 to go to the front, I would be looking at the back side of the part that I actually care about. So it's I don't know, a mental convenience thing. So yeah, forwards is backwards. I make a point to model my components in such a way that when you hit Control 7, you end up with the part sitting in front of you, or you end up with a part on the screen like you would hold it in front of you if you were looking at it from an isometric perspective, which just makes things easier for having brain farts on your stream. It just makes it easier to like hit Control 7, go to your isometric perspective, and get it as you would hold it in your hands. So we're going to go... We're actually... hang on. I don't want that boss extrude first, and I'm going to add a plane. Oh, hang on. Okay, I've already got equation spacing in there, and music's kind of loud. So I'm going to do this with planes. I'm going to do this the right way. We'll start with an offset on the right plane in the other direction. We're going to make this equal to, well, we'll say 10 for now. But then I can click on the plane and it'll show me the dimension, and then I can say equals, down arrow once, right arrow, get to my global variables, bracket spacing over 2. Rebuild, and now it ends up where I want it. I can bring the sketch down below, edit sketch plane, and say I want this on my, well, it'll be the left side of the bike interface plane. I have to be offset from this guy for interfacing with a bracket, so I should probably do that first. Yeah. This sketch is going to be our outer capture, so exit sketch, and this guy gets to be a thin extrude now. Say 2 mils is probably fine. 3 millimeters thick, other direction. Hide that plane. Cool. There's our first surface. I think I'm going to do this probably the first half, roughly. And I have to think about how wide I want the center part to be. So let's do a plane. We're going to use our first plane as a reference. Let's bring it in, say, 20 millimeters for now. And we'll figure out exactly how much we want that to be later. Ooh, I just realized I want a squared surface in the back of this guy. I'm going to do that with a second extrude. Even though it's not perfect, it is something that I want really in context, so. Whoops. Whoop. Oh, jeez. Okay, let's add some dimensions here. 60 and collinear. Make these guys equal. Well, equal's not as good. Tangent to the line is better. So exit sketch. Yep, close the sketch that way. And now we're gonna go. other direction, up to surface. Well, better than doing up to surface, in case the surface changes later, I can do D1 at extrude 1. Or, hang on. Boss extrude 1? Oh wait, am I boss extrude 1? Oh, I am boss extrude 1. So this has to be extrude thin 2. And now I have a little rectangular ear, which means we can print this guy flat on his back. I'm going to try and maintain that flat surface all the way across the back if I can. So now what I want is I have my first plane, which is my left side face plane, and this is left cross-section plane. Well, we'll call it the left primary cross-section plane. Let's just sketch on it. And we'll show this sketch so I got something to work with. And we'll hide the body too, so I only have the sketch. But that's not going to work because I care about interfacing with the body, not the sketch, so... And the sketch is actually easy to guess too, so I can hide that. So we'll convert this guy, trim all that stuff out of the middle there. Let's do kind of this guy. Call that tangent down there. Draw this line up here. And we're going to trim all this stuff off too, because we don't want that in our finished profile. This, okay, I thought that said it was fully constrained for a sec, which seemed weird. Parallel, cool. Now I have... I don't know how I'm going to make that come in cleanly, but we're going to figure it out. Let's see, so we want to call this the left capture thin extrude. Then left capture extrude backside, I don't know. Left capture backside corner. A really sharp backside. And now we'll add another sketch on this interface plane. We're just going to straight up convert that guy and then make myself a profile to extrude from, or extrude up to rather, when I loft. So now I've got that profile. Those match up well enough. Yeah, okay. I think I can swing this. So let's hide this plane. Whoops, I hit the sketch, not the plane. I'm gonna do lock the boss from this guy over to this guy. Ooh, that's actually not bad. I like that contour. It's not perfect, it definitely needs some kind of regularization, but let's just do a normal profile and see where that gets us. Ooh. Yeah. Fan of that. Okay. That gets us partway there. That looks like it didn't mirror. Oh no, it did. Okay, that's all one body. I don't know what we're listening to now. The Trip by Still Corners. I'm gonna skip it and just start a radio based on something else. Because I can, and nobody can stop me. This is If You Can't Vibe with the Peter Criss Jazz. You must be... I think the rest of the song title is crazy, but it's like a 15-word song title because that's math rock, so... Let's try a quick mirror about the right plane. Bodies to mirror, just this one. What? Oh, merge solids. If you leave that checked, then it throws a fit. Yeah. I'll probably have to chamfer that backside or something at the end, but not come later, so. Ooh, I should fill the inside of that too. Just a little bit. It's gonna happen early enough that I'm okay with doing it. Well, no, I'll save it. Because having those hard surface in there could be handy. It's easier than referencing the sketch too, so. This is the transition section. This is the left to right initial mirror. And I think what I want to do, actually, is extrude... Whoops. Let's grab this sketch here, and we'll say up to surface and right plane. Merge result. And then we can just, the mirror will stitch that all together for us. Oh, whoops. Hang on, I changed the boss extrude instead of the mirror. Whoops. Bodies to mirror, merge solids. Cool. Cool, 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 cool. This is the left to center extrude. And we'll just delete all these extra features and get those out of the way. Especially because those 3D printing coordinates are no longer going to be useful because we're not printing the back of a tiny coupon anymore, we're printing a pretty big piece. Should get some calipers out. This is the part where I have to guess how wide I want the core to be. Because we have to have sort of a detent section in the middle. Pull up the old bracket. Or no, it was rough crossbeam. Here we go. Once SolidWorks decides it wants to load it. I think I'm going to go for maybe a 40mm wide section in the middle. That seems fine. Oh, that's no good. Okay, well that's saved, so I'm just going to go ahead and close this. And SolidWorks is going to crash, because that's what it does. Ooh, No One Cares, Via Luna. Great song. It's got a later on riff that's just... it's excellent. Okay, so... rough cross. Hope it loads. Or is it just going to also crash a second time? Maybe it's just going to crash a second time. That would be... kind of disappointing but unsurprising. Man, that sucks. Because it's... I mean, I already had the whole concept kind of mocked up, so... Saved me some thinking. Oh well. Turn up the musical. So we're going to do extruded cuts. I'll just jump right into it. So extruded cuts, we need the sketch we've been sharing from earlier. And I need to grab, I think, those lines. Well, hang on. No, because I have... One of these lines is good. One of these sets of lines. We'll just convert all these. Then hide the body and think about it for a sec. Hiding the body, very important. How else are you going to get away with doing SolidWorks? Extend that, which brings us back. And then, doink, just trim that right off. Well, whoops, hang on. Trim tool, get rid of all that. Then I have to decide... I think I definitely want this to be full round, so we'll pick this edge up here and make this tangent, and then when I add clearances later, I'll just have to remember to add that. Got it. 200-pound gorilla, I will design for that much prevention of shaky silliness. Oops, I forgot I need to add my detent down at the bottom. Let's do... It's going to be a mid-plane extrude anyway, so we know that much. 80 mils of clearance. Oh, whoops. Rebuild errors. Here's a fun thing that I didn't know until fairly recently. If you don't have a body shown when you run an operation, it'll just assume that it doesn't want you to cut there. So, operation failed due to geometric condition. That's weird. Why is it failing? If I make it shorter, does it work? Oh, it's running into issues being over here. Okay, so that actually makes sense. And on top of that, it's not capturing the bit back there. So, kind of dumb of me to chop that bit off. So we're gonna undo that. Trim, get rid of that. Trim that guy, and convert these. And then I can add back this tangency feature, or I can add back this tangency feature. Oh, hang on, why is that not defined now? Oh, it's no longer horizontal. Oh, it needs to be perpendicular to something, so I'll make it perpendicular to this guy. But at the same time, I kind of need these guys to be further away so that I can extend further into this sort of cutaway section. I guess? Do I? It'll have a face beyond the bracket, yeah. I think. I think that's what you're referring to. I have a measurement of the bracket thickness, actually. Yeah, 3.5 mil. So this actually needs to be a little further, so good thing I checked that. Or good thing you called me out on it. So let's do that. Come over here. The blue ones are feature dimensions, so things that apply to the feature rather than the sketch that it's pulled from. So you can click those, and everything breaks suddenly, which is very cool. Oh, it made a different... This one suddenly decided it didn't want to merge. Why didn't it merge? Oh, rebuilds and it works just fine. Figures. I am going to come into this cut extrude sketch, and I'm going to say, so, select chain, deselect the one at the bottom, and then offset entities. Don't select chain up here, because I just want the one that I've selected. Cap ends with lines. Construction geometry only on the base. And then make this like 50 mils. So now I can make this as large as I want, and it's tied to my existing geometry. Oh, you want it to have the end capped as well, right? I'm guessing that's what you mean. That's that shouldn't be too difficult. I will have to probably make a little cutout here so that it can come out just fine, but that's just adding a cap, so. And that should print pretty well too, which will be nice. But I do want that to have... Ooh, how thick is this actually? Only 2 mils? Let's put that up to 3. So we'll come over here to this sort of inconspicuous dimension. Make that a little bit thicker. Oh, goodness. Oh, goodness. Why did that work just fine with 2 and then not with 3? Oh, not 21. Yeah. Yeah, it will be. 3, and then it just breaks it. That's very rude. What happens if I do 4? It gets worse. 5? Stays bad. Okay, I think I have to do... I should draw some guidelines here, so... What, with the weird kind of butt crack? I try to avoid drawing butt cracks in my parts where possible. Oh, it does look kind of cool. It's growing on me a little bit. I don't know. I could fix it later. It does have kind of a cool look to it. Doesn't need to be that thick though, so we can bring that down to 3. Ooh. Whatever, whenever. Big old muscular butt. You have 2 muscular butt cracks on the side of your part, so that's cool. Whatever, whenever. By this town needs guns. Good stuff. I probably should add the caps before we do the mirror. So we're gonna go all the way back to this, where we've got the corner. We're gonna do an extrude. It's gonna have. I'm just gonna have to straight select the face, which isn't great, but it is what it is. So we'll trim that up. Ooh. Oh. Let's do something kind of like this. So we're gonna trim this guy. I want this to be coincident with that line so that it's sort of tangent up there. I want these two to be equal. I want this guy to be tangent down here. Whoops, tangent down here. Alt A. Whoop, that's gross. Oh, it's only tangent in one place. It needs to be tangent in 2. Tangent. Tangent, 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 tangent. Cool, that looks fine. We'll call this maybe 4 mils. And that'll give us clearance for the metal bending out there, or should. And we're gonna make this equal to D1 at left capture, then extrude, which I'm just gonna take a wild guess and say is probably the right thickness. Yeah, it is. Cool. Now we got a pocket. I hope that fits. I don't think it should have any issues with fitting. Can I chamfer this safely? Like when it comes down to it later on. Oh wow, yeah. Probably don't even need anywhere. I don't need anywhere near that much, but if we make it maybe 4. Cool. Just for, you know, now I have to check this. We make these 0.4. Yeah, that's very doable. That'll clean up real nice, I think. I'm not going to do those chamfers and fillets just yet, though. So let's shrink our tree down a little here, clean it up. So we've got this guy. We're going to hide that sketch. And now I have to start thinking about the mechanism in the middle here, which I haven't fully fleshed out in my head yet. So initially I had a semicircular sort of captive, prevent the two bosses from rotating thing at the bottom here. But it occurs to me that I don't really need that because I don't really need that because those flats should keep it from rotating too much, but I still kind of want them there, so I think I'm going to add it anyway. Just to have a sort of guaranteed these things will not flop around here. So we'll pick these two guys, make them equal, make this 2.5 is fine for now. We'll get the clearances later. Oh, we do need to go all the way through. Let's do that right before the mirror. Hole wizard. Did I save what diameter that hole was? 6 mil. Okay. I'll do hole wizard, probably 6 plus or normal clearance. Hey, check that out. All already set up. Right on the origin, through the whole part. Mirror, cut, extrude, easy peasy. Almost like I knew what I was doing. Okay, so this is 9.6 millimeters, which is kind of a weird size. What is that based on? Is that based on the... Because it's 3 millimeters in radius larger than... Yeah, okay, whatever number in there. So now... Ooh, I could have this be round, actually. That would be kind of cool. Nope, I could not. I could not do that. Because if it was round... Oh, here, let me do a right side cross-section here. If this was round up here, then it would be really difficult to make it so that it sort of curves and gets out of the way of the motorcycle bracket, or the GPS bracket, which I should probably just go design right now, so that I have it, I can start thinking about this in an assembly context. So, features, extruded boss, top plane. This is going to be a rectangle with feelings, so. Center rectangle. I'm going to do this with my centers first, so I know that we're doing an amps hole pattern, so 38 millimeters side to side, 30 millimeters vertical, I think. Let's see. What model Garmin do you have? It's a Garmin Newbie 650, I think. Nope, that's not it at all. 950? Garmin motorcycle GPS. Glove compatible. Ooh, shiny new GPSs. Adventure, Stamina, and Anger. Good song by This Town Needs Guns. Okay, so it's a Zumo. Zumo 9 something, it's like a 930. I think it is a Zumo 930. A whole bunch of juice, apparently, is also named Zumo. I'm just going to assume that it's horizontal, and then if it isn't horizontal, I will fix it later. Because we can always reprint this part. It's just 2 numbers, so... Oop, I made these construction too soon. I need to have them be not construction, so that I can offset... centimeter? That seems fine. Amps hole size. I want to say it was M3. Okay, these numbers are in inches, so 0.2... Wait, oh, is that the outer radius? Okay, whole radius, or whole diameter is 220, so 0.220 inches in millimeters. Zumo 660. Okay. Turret Tech and their stupidly overcomplicated mounts. Hey, there we go. Okay. Whole bunch of numbers. 660. Oh, this guy's selling 3D printed caps. For $100 a pop. Oh my god, dude. What am I doing? Not selling stuff for $100 a pop. Not to mention his surfaces don't look that great on the bottom either. My god. Well, that's 0.220 inches is 5.6, which I'm happy calling that M5. So we'll design this for M5 holes. And this one says 0.2, so 0.2 inches in millimeters, 5 millimeters. Yeah, those are M5 holes. And I'm not going to dimension each fillet. Let's add all these guys here. See, that is D3 at sketch 1, so I'm going to set this guy equal to D3 at sketch 1. Easier than, I mean, I could link them. I should link them. Okay. Right click, link values. Amps, mount, oversize. Okay, that seems fine. And we're going to call this 6 mil thick. Seems fine. Extruded boss. I'm going to be designing this one mostly in printed orientation rather than use orientation, because when it sits on a table, it's going to sit there in print orientation. Whoops. Okay, so we've got our overall thingamajig here. That's or 665. Yeah, those were the two that were glove compatible, if I recall correctly. Get rid of those. And this was 19.6? Nope, that's radius. 19.6 over 2. There we go. So, I've spent multiple hours Googling that. I can't find a DIN standard for that thing anywhere. It's called amps, which I know that for sure, but I cannot find any information about like what the actual standard is. It's not in Visa or anything. DIN standard GPS mount. Actually, I bet I'm gonna make myself look like an idiot. DIN standard amps GPS mount. Yeah, I looked all over. I couldn't find a DIN standard for it. Maybe I just suck. Like that's always a possibility. Oh, Mirror House, Via Luna, also a good song. I'm gonna do. Well, yeah, we found a standard, but the standard is just called amps. As near as I can tell, it's like advanced mobile or advanced mounting pattern something. But it's like a generally accepted standard, but I couldn't find an actual like standard document for it. It's just a thing that everyone said they were all going to do, and then they did. It works. It is just very strange. So, through all... Well, oh no, I don't want to do a through all. I want to do a midplane, because this has to fit in between. So let's... Whoops, hang on. Full Wizardo. If you mouse over the edge, you get center line. And we're still on M6, so we're nice and all good in that regard. Oh, I need to come down here and I need to do the whole pattern. Oops, old wizard. So now we're doing M5s, pattern, and we're gonna go with this boss extrude. Show the sketch on here, and then we can just click our existing four corners. Lines right up. And now if I change that in the future, like if I go in here and say this is 30 now, this is 38 now, it just goes to the right spot. Let's change that back. Oh, M4 fasteners. Based on manual. Okay. Sure. Yeah, I can see him maybe being a little bit loose or something, so better to have it be on the board. And we can always drill them out, so. And the pattern is flat, right, on the backside, I think. Let's add some fillets. So I'm gonna have to cut into them. Say clear selections and see if I can't select loop. Your other loop. There we go. Flat on back. Okay, that's good. Maybe I want a little bit of chamfer. Maybe 1 mil. The question is the fillet going to capture the loop nicely? It will not. Nuts. Yep, as soon as that gets over there, it throws a fit, so we'll just not have the chamfer there yet, and we'll chamfer that after the fact. Well, do the chamfer now, why not? Ooh, hang on, that won't work. Whoops. Can I do an edge keep away? I've never actually tried that. Partial edge. Ooh, setback parameters. I think I'm just gonna have to do extruded cuts on both sides to clear that area out. Ooh, no, I just can't even do it on that side, actually. I straight up cannot fill it there, because those have to be flat faces to interface with them nicely. I mean, I can do tiny fillets down here, like maybe 0.4. And I can make this less jacked up. That's way jacked up. Keep edge. Keep surface, please. Or don't. I'll shrink these down a little. Holes are 30 and 38 centered on center. Okay, yeah. I did find that. I could confirm that, but it was really hard to confirm anything else. So now we'll do an extruded cut from the top plane, and we'll just pick this one. 48 mil diagonal. Ooh, actually we can just check that. Exit sketch here quickly. Come on, let me exit the sketch, please. Center to center, yep, 48.3. Hang on, why is that saying? Oh, what is it doing? Oh, it did point to point. Center to center, 30, 38, 48.4. That's well within tolerances. Here's the part of the show where Clark forgets nut diameter. Width across flats, 7 mils. Cool. Oh, we're still on the sketch. Cool. Call this guy 7. Cut out for the main bar fasteners. I'm not sure which ones you're referring to. You mean the one through the side? Get this squared away. Offset, and totally forgot. Okay, 3.2 millimeter thickness, so we want to go at least that far in. Draft outward, 5 degrees. Sketch-driven pattern. Selections. You can pick up the one from the whole pattern earlier. And then grab the feature. Reference point centroid. Hey, cool. Went to the right spot. Yeah, there we go. Oh, hang on. Message. Oh, okay. Nothing super important, thank goodness. Maybe I want a little more space on the backside here. That wouldn't be too hard. No tangent. Get up a little. We do this guy. Oh, I have to draw an extra circle here. Make that construction and co-radial. So we're going to say 3 millimeters there. And then I can have a 3 millimeter fillet all the way around the base without worrying about it. Can I round the corners too? It will let me round the corners. What if I do like 3.5? Okay. It does break after 3, so we're going to stick with just 3. Oh, but then I can do the chamfers, so I don't want those fillets. So, no round corners. Ooh, I can make this equal to that offset, though, so that it's safe. So, D2, Sketch 2. Come over here, double-click, D2 at Sketch 2. So then if I make this like 5, I get bigger fillets. And I know they'll always clear. Yeah, what I'm going to do is... there's going to be 2 notches, 2 little V-shaped notches in here. I have yet to determine the angle and depth, but that's something that may have to get experimented with a little bit. But well, actually, it wouldn't be that hard to do now. Okay, I have to figure out what I want kind of the natural position to be. Plane, front plane, we want angle 20. Oops, we need a second reference, which is right plane has to be perpendicular. Oh, 2 planes should have mid-plane constraint. Bite me. Plane within that. Oh, I have to have a line. Axis. There we go. Now I have my... Let's name some stuff for a second. Base plate. Hinged mount. M6 through hole. M4 amps mount hole. And hinge mount fillets. Hinge mount. This is the M4 nut cutout and the M4 nut cutout pattern. This is the hinge axis. So these are amps fastener pattern. And there we go. Okay, that's all sorted. And we'll call this the amps hinge component. Okay, so now I need a plane. It needs to have hinge axis. And I need to have it at kind of an angle relative to the front. Well, relative to the top, actually. Whoops. That seems like kind of a normal guess, and then we'll come maybe 45 degrees upward for the next one. That seems fine. Yeah, that's... If I had... if this rough crossbeam was working, like it's impossible to see on my screen, but I did have that as a feature. It just wasn't quite as well developed, the concept. Almost 90 degrees. Okay. Oh, that's right, because you're trying to avoid glare, too. So. So I'm going to want the... Over on this side. This is roughly... Are you going to want the first face to be kind of almost directly vertical, you think? Because then I'd want the first, hang on. I'd want the first, which one of my hands is vertical here? Almost 90 degrees apart. I'll do like 80 degrees. I'm just trying to make sure that all works out of my head so that when I draw it up and, well, once I have it in an assembly, it'll be a lot easier to tell, but I should probably just work on that. Okay, vertical or nearly so, flat first, and then it'll come up most of the way for the other position. So this actually looks about right. Except I want it not in that orientation, I want it 110 degrees out. Sketch, not sketch-driven pattern. Sketch, please. And then hit N for normal. Let's convert this guy. And we'll do... Let's see, I think it's one edge first. Okay, we're adding construction lines from the corners. Oh, whoops. Did it in the wrong orientation first. figure out a rough depth for this guy. Say 3 millimeters is probably fine. I mean, the angle is going to matter a lot more, so I should probably just... Whoops, trimmed out too much. That line, do need this line. Let's see, these guys are equal, which is good. Select midpoint, make this guy, make that the midpoint. $110. Nope, can't be wider than... Let's stick with 90 for now. So now we can do an extruded cut. Ooh, we can't just yet. Have to mirror this first. And this guy can get hidden. It's kind of annoying. And that axis too. And mirror. Exit sketch. Okay. Extruded cut. Mid-plane. 20 mils. I wish I could extrude up to just this surface. That would be kind of nice. Let's try maybe 25. Ooh. I should extrude by exactly twice the distance from the center from here to here. So if I come back up here to the hinge mount, and I add a dimension here, 12.8, D3 at sketch 2, it's construction, it's fine. We can come up here and say equals D3 at sketch 2 times 2. And then it should, let's see, rebuild that. Then circular pattern, direction, this guy, instance spacing. We only want 2 instances. We want them 80 degrees. 80 degrees, 80 degrees is probably fine. Features, just this guy. Though it's going 80 degrees in the wrong direction. Oh, that looks real ugly. So... oh, goodness. Let's take it back. Oh, I only have to take it back the maximum size of these fillets, so... how was I determining that? I think it was another thing in Sketch 2. Cancel. Screw it. Exit sketch, rebuild anyway, don't care. It is D2 at sketch 2 is how far out I have to offset that. So make this guy construction, extend, midpoint or equal length, that's fine. I've already close enough to have accounted for that, kind of. Equals D2 at sketch 2. Did it get rid of my... It did get rid of my equal length. Why is that not constrained anymore? Oh, I see. The line is no longer coincident with my other lines, so if I make it coincident again, it lines right back up. That looks extra gross, though. Let's see, can I just delete face? Oops, come on, get that one in there. Delete and patch. Yeah! That is exactly what I was looking for. Oop, didn't get mirrored though. Whoops. Oh, goodness. That's not hard to fix though. Just select the polygon again and mirror. Get your right Doritos in the right place. See if delete face will work nice twice. It totally does. Almost like I know what I'm doing. Hang on. Oh, wait. Oh. Oh, go away signal. Okay, so that gives you one like this, and one kind of like this, which seems pretty close to right. I don't know. I'll make two different configurations mating it later on. So, first detent cut, second detent cut, second detent cleanup. And this is the detent sketch plane. Whoops, hang on. Pipsy. All this stuff, detent features. Amps, features. Yeah, that's not bad. I think I just add in fillets there and that should be fine. So let's go, let's see. Make assembly. Detented GPS bracket. Load it and make the origin, because we live in a sane world with assemblies that are constructed by sane people. And save. 1190 GPS bracket assembly. Hinge component. So we'll just mate this right plane right on the other right plane. So they line right up. And mate that guy over there. Hang on, I don't know why that's transparent. Yeah, that's looking pretty good. Almost like I know what I'm doing. So we'll call this vertical position, or rather, call this down and then add a configuration for up. And then we can mate this in two different configurations depending on what we want. So pick this guy, mate that one parallel in this configuration. Oh, whoops. I did that wrong. This parallel wants to be with the other one, so we'll just configure that to be suppress it in the up configuration so that it's only active in the down configuration when the GPS is down. Now we can come back to up and add another mate. Pick that edge and this one. Down, up, down, up. Cool. Now how are we doing for interface down here? It's this actually parallel with the top plane? Did I manage that? By accident? No, it's got 5 degrees of angle on it. I bet this is 25 instead of 20. No, it's 15 degrees. That's fine. A little bit of tilt up, I think, is probably warranted. Also, I still have an active sketch somewhere. Because I've got something with points. Visible. I think it's, yeah, it's my amp splining sketch. Now, before I do those detents, I would like to add a chamfer here. Okay. Detent still work just fine. Pre-detent chamfer. Make this one equal to D2 at sketch 2, like all the other fillets. That looks gross, but I'm just gonna not look at it too closely. Okay, so we've got our pass-through, got the bracket assembly. Now we just need our little sprung pads. I think I want this a little wider too, so 40 millimeters is fine for this bit in the middle, but that only gives us 10 millimeters of length for the spacers. I would like a little more than that. Which now is a good time to think about compression springs and what's going to fit there, because I only have springs that are sized for roughly M3 fasteners at the moment, because there was just a bag of them at work that it was like, hey, we need to get rid of these, do you want them? I'm like, yep, yes please. Okay, ID. McMaster doesn't like it when you change the size of the page. So we want 6 and a bit ID, so we'll say probably everything from this whole range is probably fine for IDs, so we'll get everything in that size range. We want pretty short too. Corrosion resistant would be good. Compressed length, max load is going to be... So we've got... Let's see. Wow, these ones are stiff as hell. 6.4 ID and 9.6 OD. How long are those? 9 millimeters at compressed length, 14.5. Good lord, these are stiff little buggers. How much are these? 15 bucks for a pack of 5? Yeah, that'll give us spares to construct 1 or 2 of these. And an extra if one breaks. That's also like crazy high pounds per millimeter. Oh, I should do some math on this. What's the twisting gonna be? So we have to move it back. Okay, hang on. Let's go do some really rough figuring. So we've got this guy. Select midpoint. That's roughly 7 millimeters from the center. We have to push back a total of 3 millimeters. So whatever the rate is at 1.5 millimeters of compression. So 50% more than the rate is the total. Okay. 3 millimeters total length times the total maximum force that we're going to have to push past is going to be equal to... Oh, goodness. I'm just going to wing it. You know what? This is going to be what it's going to be, and we'll tune it afterwards, and we can buy more springs. And if we find that something is too weak, we can preload it. And if we can just print spacers. We can just print spacers. My goodness. Okay, give myself some extra room in there. Come look at this. Oh, that's almost a little too far, now that I look at it. 70. Maybe you want to bring the thickness of this guy back to maybe 35. Is that going to break things? Nope, doesn't break anything. Nice. Haven't heard this song in a while. So we've got quite a lot of extra space. Weak is probably better. Yeah, probably. We'll do 7.5 millimeters of thickness nominally, and it's not too difficult to. Hang on, how long is this? Oh, it's not a round number. Gross. Is this a round number? No, also gross. No. Because I really want to match this profile if I can, so. Actually, I'm just going to Control-C that and see what happens if I go into a new file and paste it. Like, just Control-C face. Sketch, right plane. Oh, insert without sketching. Okay, so it's going to be a little tricky. But we know... Okay, we'll just do this kind of from first principles. We've got rough shapes, doing some rough shapes. And then we do kind of just a little bit of a bend inward here. And this does not, midpoint of this line does not line up with the origin. So I have to add a separate control line for that. And this guy is tangent to that. This guy is 19.6 divided by 2. And this distance is... Hang on, how did I do that distance? Uh-oh. Did it without math. That means it's going to be really ugly. Oh, no, it's just tangent. Really? So center to center on these should be the same. Center to center, 9.6. How convenient. So we can just pick this guy and make him tangent over here. And we know... Oh, hang on. Please be tangent. Not tangent? That is tangent. Okay. So that looks about right. How did I come up with this length here? Can I pick a different reference frame? I know there's a way to do it, it's just been a while since I've thought about it. Let's come up and look at the initial. How long is this guy? Oh, is it not defined? Am I that guy? Oh, I just said it was 25, so this is going to be a gross number. No! Okay, so I just have to kind of match it. Goodness. Okay, 6.32. What's that in way too many digits? Which is millimeters. Millimeters. 6.32 is close enough. .32. Now we just have to. Oh, this just needs an angle on it, and I think we're good. Nope, still doesn't want to be. Still doesn't want to say where it is. There we go. It just needed that tangent to the bottom. So now we'll get this kind of tumor-looking guy down here. And that guy is coincident with the bottom, so we'll just do that. Features, extrude. I'm going to extrude to the right because I'm dumb and I should be extruding the other direction. Can I just flip this? Every once in a while, I wonder if there's something weird I can do by right-clicking on dimensions, and I'm almost always wrong. So we'll go the other way. Extruded boss. Top plane. Reconstruct our triangle from earlier. Origin, make it the midpoint, define all our characteristics as we had before. I think it was 3. And this one was also 3. Then we need 100, I think. 100 sounds right. And then we'll do through all and through all. But we won't merge, and the reason why is because I have to trim this to exactly match the existing sort of profile. So I'm going to do that with offset surfaces, because that lets me get really good control over it. So no offsets, just pick, whoops, not that face, just these faces. Okay. Intersect. Nope, not the boss extrude, just the surface, please. And then this boss extrude. Intersect. I guess it wants me to extend that first. Extend surface. Ooh, I'll do untrim instead, because that's a little nicer to... let's see, select open loop. We'll do 100%. And that'll go the full length, and it'll always, should always clear no matter how thick I make that, so. Intersect. These two, intersect please. I want to keep only this region. Whoops. I was wrong. You click the ones you want to get rid of. And I want to make that consume the surface too. This little checkbox here. And then it gets rid of the surface left over. Now, if we unhide that body from earlier, we can combine, and cool. Now we've got our little divot. Do a whole wizard from the backside of our newly completed part. And this is going to be an M6 normal clearance as before. Mouse over our arc to get our center. And we're good. Okay. So we'll call this the detent slider. I get the feeling that these might need to be a little less slopey, but we'll find out. Ooh, I need to make a mirror configuration. Just do it the same way I do it at work, a -1 and a -2. So now that we're in the -2 configuration, because I just created it, and you can tell in the feature tree -2, that's what we're in. Oh! Finger by Elephant Jim. Great Taiwanese math rock band. I haven't listened to them in like a year. I love it when that happens. So, anyway, mirror face, picking the right one just so we have something to mirror on. Bodies to mirror. Just this guy. Don't merge. Realize that you should rename all your features. Slider base. And this is triangle detent extrude. Base perimeter surface. Base perimeter surface lengthen. And this is intersect trim triangle detent with surface. Well, it's implied with the surface because that's what intersects do. Combine, add detent to slider. That's M6 pivot hole. And then this is the mirror for -2. Yeah, I might actually, mightn't I? I could have, I have a solution to that, but it's kind of hard to articulate. I think maybe I could have like a track that a little feature slides in so that it stays in the middle. I could only spring one side. Yeah. Yeah, that's a lot better, isn't it? Ooey. Nuts. That does make a lot more sense. I hate it when that happens, when I overthink something. But I can't, for some reason I want to detent the right side instead of the left side, because I already have the sketch on that side. Let's see if I can't just sort of mirror everything. I have to do some flipping here. Whoops. It ceased to exist. It entered the singularity when I did that, which was not fun. Okay. There we go. Okay. Just some quick flipping. Don't worry. Don't mind me. Okay. Part comes out the same. Almost like I know what I'm doing. Okay, so we got the M6 pivot hole. Slider on one side. I have to go over here, and with the detent, I can now, let's see, edit the sketch. This one's the one on the right side, which is the first one that already has dimensions on it. So now I just trim all this off. And the cleanup feature is going to throw a fit because it doesn't have any faces to delete anymore, which is fine. That's a sacrifice I'm willing to make. And we'll get rid of these extra missing references. And so now we have to have half of 35 one way, and some other distance the other way. Back on this guy. We can just do that with the cut extrude. So right now our midplane is 70. So instead we'll go that regular same distance one direction. And then the other direction we will go 35 over 2. Detent slider. Ooh, hang on. I should no longer... I have a mate on the hinge component that makes the right planes coincident, but that isn't necessarily true anymore because these parts can change width and be different and strange. So I should mate them like that so that it's a little more accurate to the part, or to the finished model. And now we add our detent slider. We're going to mate that coincident with... you don't want that... Yeah, I guess that makes sense, because if it's got the flat, then it should be fine. We'll just get rid of that. Hang on. Apart. Idle Promise by Invalids. Good song. So now we can do slider base, do the same thing. Delete that, bring this guy over here. Hang on, this guy never got horizontal. And... oh! Got rid of the one that one was tangent to, so... whoops. Hang on, things got weird. Oh, I see. The region's changed, so... create internal regions intersect. Oh, because it makes zero thickness geometry. I can fix that. I just... if I change... which surfaces I'm offsetting, so it's just the ones that intersect up top here. Clear selections. Whoops. I only wanted to clear the ones that didn't exist anymore, but that's fine. Now the untrim only has these two edges, which is also fine. And triangle detent's normal now. Although this inexplicably thinks that it's not the same surface. They're parallel, and the normal distance is 0 to an extremely measurable degree. But it's still trying to fit. That's really annoying, but I don't think I care that much, so I'm not going to. Okay, now we just add these two guys and say mate. Parallel. Hang on, are these... something's not right. That's weird. What's the deal there? .8, 9.6. I did a goofy somewhere. 9.6. Detent slider gets slightly smaller. Whoops. Okay, but now that all fits together. And now we add an extra mate to control advanced, I guess? Yeah. Width selections. free. It's gonna tell me that's still undefined because SolidWorks is dumb. Oh, hey, hang on. This is 90 degrees, not 100 degrees. Things you discovered in integration. $90. Cool. Okay. That is most of the way there, I think. Oh, hang on. This is no longer the -2 configuration. This is now the only configuration. So we can just call this one default now. Mechanically simpler makes a lot more sense. And that shouldn't weeble wobble around too much. I do wonder... if I should have some sort of sheath of some kind. Let's see, this will always be able to slide down on, so I don't have to worry about it being packed all the way tight, but I do need to have some play. Yeah, I'm just trying to think about how I want to shape that, because do I want this to be the overside and this to have like a plunger inwards that the spring impinges on? Do I want... I mean, yeah, that makes the most sense. I should probably just do that. Let's see, what were those McMaster spring options? Plenty of things. Let's see. Compressed lengths. Lots of compressed lengths around 10. And lots of max lengths. Looks like we have lots of options with about 5mm travel. Which just seems good. Oh man. I've been ignoring a lot of messages. Which, it turns out, is fine, so... Yeah, that makes sense. Oh, you mean the whole slider in the tunnel? That also makes sense. Okay. Yeah. Let's do that. Let's say I want... Let's see, what's the minimum distance between these two? Minimum distance is 6.3mm. So I can safely reduce the size of that by 3mm and be fine. So let's leave just a little bit of clearance here on the edge, maybe 2.5mm. Let's tweak this guy first. So detent slider. Oh, what is this? Oh, puddle. Sean, I just haven't heard it in ages. Let's see. Move face. That's the wrong direction. I only want them to be about 3mm smaller. Oh hey, that's not right. I didn't tell you to move that face. Yes, this is a very good idea, and I like it a lot. This is going to look very, very slick. Extruded boss on this. Just convert. Trim. Say yes. Thin feature, One Direction, wrong direction. Don't listen to One Direction. They're not a good band. 16. Oh, not 32, just 3, please. Why would it result in 0 thickness geometry? Oh, wait, fine. Control A, offset, reverse. Oh, because it would make a 0 thickness down here. Yeah, I can see that. Do not make any construction. And I think... Let's see, this guy needs to poof. This guy needs to get longer. Then we can extrude this with impunity. Yeah, I like that. That looks very slick. Oh, that's gonna be so cool. Needs a little more clearance, I think, but I should probably take that out on this side because the slider is getting kind of small. So we'll call this maybe... Well, I'm going to keep it nominal and I'm going to fix the tolerances later. This is going to be among the neatest brackets that anyone's ever used, which is definitely not a gross overstatement of my skill. So let's come do some finishing features on this guy. So we're gonna do very small fillets, probably come up before the hole, and add some fillets here. Make them pretty small, make them really small actually. Detent fillets. Chamfers now. Skip this. Ah, never meant. Oh, what's the diameter of this? Okay, the spring should still hit on that face, all right. So, well, will it? Yeah. So I made those 2mm equivalent diameter, I think. If I measure from there to there, oh, it's 1mm. Yes, 1mm diameter equivalent. So let's do that in here. Do the same thing over here. That's honestly like 90% of the filleting that needs to be done in this part, is just inside cleaning that area up. And then we should probably take a look at this structure. So this is the center section cutout. Slider tunnel thin extrude. And we'll call this the slider cavity, actually. Well, no, slider tunnel's fine. Slider tunnel interior fillets. Get these fillets in here. But these guys want to be pretty small, like probably 0.4. just some minor chamfering on it, honestly. So we've got the ab pocket fillets, interior fillets, chamfer. Let's see what a 1mm chamfer looks like. We just kind of go nuts with it. Oh, pitches a fit if we go that way. That's kind of fine though. I like having that. That shape there is fun. What? Oh, it doesn't throw a fit on these ones though, which is kind of nice. Bet we can do that one too. Wow, that's 90% of the way there. I'm gonna add one of this too, or one of these two spots. Oh, bolt head cutouts on ends. One could hold the other. One could hold the other round for nuts. Oh yeah, one could hold the head and then the other, and then it just sticks out the end. Is the fastener long enough for that? I remember thinking it was, we didn't have a lot of spare thread, so like this extra 3mm could be hazardous, perhaps. Left and right parts, yeah. So like a hex head cut out here. So we'll come back here before the fillets. Extruded cut. Let me do the hex cutout first, and then I'll see, make these parallel. And it's an M6. Dimensions. I guess if it fails, we just drill it out, so. No, that's socketed cap screws. I want hex head cap screws. McMaster. I'm just gonna check McMaster. Hex head cap screw. M6, just give me some numbers. Head width, 10 mil. 10 mil. Maybe it should be a little bit oversized. Okay, so there's the hex head cutout. And then for the other end, what you're saying is leave it open and circular and large enough that you can get like a socket over it, I assume? Because if so, you're going to have to go measure the diameter of a 10 mil for me. Cool clearance. Okay, so clearance for socket. Let's see, so those are spanner clearances. That's not what I need. Box end wrench. Yeah, probably. I'll set it to like 14 for now. And then tell it to do up to surface, up to this surface. And I think I want these... Well, no, it's probably better that they come before the fillets. That does look very slick. Okay, what else? So we got our spring with thing. We got our spring detent. I think this model is honestly just, that's pretty much it. It's there. Needs a little more chamfer. Yeah, I think this is pretty much there. All these parts are very printable. We need to figure out a spring for the detent slider. As it is, we've got... what are we listening to? It's good, but it's very strange. Faded in the Morning by Unknown Mortal Orchestra. Yeah, I think I can do that. These ones are going to be a while for sure, just because they're kind of large. I really want to know if I've got that clearance right, though. Ooh, and it didn't do that one right. So, hang on. Time to go obsess over some fillets. Yeah, the detent angles are probably going to need some tweaking, but, I mean, they were always going to need some tweaking, so I'm not too worried about that. Can I do both of these at the same side? Nope, cannot. Throws a fit. I wish I had a 10mm socket handy. Hang on, I could just Google that. I know it's going to be, let's see, M6 nut flat width. Width across flats, 10. 10mm. Okay, this won't be final. Are you sure that you've got enough for it? 10mm socket diameter. Metric socket outside diameter part. Okay, so if it fails, then it's oh well. Product standard B 12 point D. Here we go. Part number 6. Socket nominal size. Drive end 14.75. So we'll go with 15 on this. Whoops. Save. Yeah. It's gonna work. Even if it's not the final one, it's gonna work. And we got plenty of section through the bottom to keep this thing stiff. The whole thing will be compressed together. Oh, this is gonna be so slick. And plenty of space to like react that down. I mean, it's not gonna be on the center line, so that you're still gonna get some compression across the top, I think, and maybe a little bending. But oh, see if I can sell this idea to Touratech. Do you guys want this overly complicated bracket I designed? Oh man, that looks great. I'm really stoked about this. This thing's gonna look awesome. Ooh, need some extra clearances there. Let's come back and do that just before the fillets. So this is the hex head restraint, and this is the nut socket clearance. We're gonna do a little bit of move face. We only need like probably, well, I'm gonna go with 0.2 flip direction. Give ourselves definite safety. This is among the nicer things I've ever designed, I think. It's gonna look really slick for sure. It'll be downloaded and appreciated by one person. It'll be worth it. Okay. Ooh. Next Year by Just Neighbors. Another good song. See, it threw a fit when I did that one earlier, but it didn't seem to throw a fit with these two. I'm just gonna not think about it too hard. Oh. I'm really, really happy with this one. It came out really well. I'm going to tweak this. Well, nah, I think it's fine to have that big flat face back there. Thought maybe I could make that chamfer bigger, but I'm not sure that improves it. Okay. Let's see, how long have I been going? Wow, almost 2 hours. That's quite a bit longer than I usually do. I don't think I'm going to stick around and do the sit up on stream, because that's just run-of-the-mill Kira stuff. That's not the interesting, 2 hours from concept in someone's head to pretty close to finished parts. I mean, obviously these detent angles are going to need some tweaking, but yeah. Talk to you later. I might be out next weekend for the Best Guess Enduro, maybe. I don't know if you saw that email, but yeah. To all the people watching this when I'm a huge YouTuber someday wondering, what's the Best Guess Enduro? Doesn't matter. You didn't see anything. Yeah. To people watching this later down the line, thank you. If you have questions, leave them in the comments below, and I will do my best to answer them. I'm just now realizing that I forgot to add some fillets in there, so I'm going to go do that. Whoops. What else? Let's call that 0.6, make those match. Can't believe I almost forgot those. Not the whole face, please. Beautiful. Beautiful, beautiful, beautiful. That's gonna look really nice. Yep, I'm just gonna go print this now. I just broke some of my mates for some reason. Whoops. Oh, it's because I deleted those edges. I can fix that. And this guy, instead of being a width mate, hang on. Let's see, I don't want this to be a width mate, I want it to be just butted straight up against it, so it's gonna be back to a standard mate. But it still wants to have a width for some reason. Whoops. Hang on. This face is going to always be touching this face, so that makes sense. Okay. Let me just make sure that the up configuration still works. Nope, that one breaks too. Okay, parallel is broken for some reason. Ah! Coincident. Oh, parallel. Whoops. That's wacky. What? Okay, I think this guy... Unsuppress. 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 Make sure, okay, fully defined in this configuration. Fully defined in the down configuration. Looks crazy kick-ass. Okay, now I'm going to print it. Good night all. Thank you for watching. Leave a comment, etc. All that fun stuff. Boink!